Okay, let's dive right into this. Welcome to a completely different, high-energy, application-first explainer for Cambridge Syllabus 0625. If you've been struggling to get those top marks, you are in the right place. Today, we're introducing what we call our Master Chef approach to absolutely dominating physics motion graphs. Think about a Michelin star master chef for a second, right? They don't just walk into a kitchen, dump a bunch of raw, unpeeled potatoes and an uncooked steak onto a plate, shove it at the judges, and expect to win an award. Obviously not. They use a highly precise recipe. They have to carefully gather their evidence, which in this analogy are the raw ingredients. Then they apply their technical analysis, which is the actual cooking process. And finally, they evaluate the final product, which is the plating, making sure it perfectly fits what the customer actually asked for. Listen, if you are sitting in that exam hall and you're just dumping raw, memorized physics facts onto your exam paper, you are quite literally handing the Cambridge examiner raw ingredients. It doesn't matter how fresh those ingredients are, nobody wants to eat raw flour. So today, we are going to teach you how to cook. We are going to completely transform the way you approach your Cambridge examinations. We're going to do this by grounding absolutely everything in real-world application before we even look at a single equation. We're taking those red pen marks and we're turning them into green check marks. Let's get started.
So, I want you to ask yourself a serious question right now. What physical effects, measurements, or safety features actually depend on understanding motion graphs? Before you draw a single axis, before you try to memorize some dry, confusing formula from page 42 of your textbook, you really have to ask yourself, why does this stuff even exist? Motion graphs aren't just some decorative mathematical art meant to torture you. They are the strict governing rules of the physical world around us. If you want to build a bullet train that doesn't derail on a curve, if you want to design a roller coaster that is thrilling but completely safe, or if you're programming the automated emergency braking system in a modern electric vehicle, you are relying entirely on the principles of motion graphs. Every single millisecond matters. By understanding the real-world necessity of these graphs, the math suddenly stops being something you just blindly have to memorize. It starts being a tool you actually want to use. It becomes necessary to solve real problems. And trust me, this mindset shift from "I have to memorize this" to "I need this tool to build something cool" is exactly what you need to conquer your exams.
Here is our exact recipe for today's lesson. Number 1, why motion graphs matter. Number 2, upgrading from everyday to physics vocabulary. Number 3, our 4 steps to success. Number 4, dodging those common physics exam traps. And number 5, your key exam revision prompts.
Let's jump right into section 1, why motion graphs matter.
Okay, we need to talk about two very typical students we see all the time. Honestly, you probably know an Alex or a Sam, or maybe you've even been one of them. On the left side here, we have Alex. Now, Alex works incredibly hard. Alex stays up late, memorizes every single page of the revision guide, and when they get into the exam, they completely overload their answers with raw physics facts. We're talking massive, dense paragraphs. But Alex completely lacks analysis. Alex doesn't actually answer this specific question being asked. They just write down everything they know about a topic. Like we said earlier, Alex is handing the examiner raw flour and eggs. Then, on the right, we have Sam. Now, Sam actually understands the core concepts really well, but Sam rushes. The clock is ticking, the pressure is on, and Sam completely misses the specific command word requirements in the question. The question says explain, but Sam just states. And what happens? Both Alex and Sam end up losing massive amounts of marks. Their past papers are just bleeding with red pen. Why? Because they treat physics like a simple memory test, instead of what it actually is, an application test. The examiner doesn't just want to know that you've memorized what a curve looks like. They desperately want to know if you can use it to solve a problem.
And this brings us to exactly why a top-tier student, someone we'd call a true master chef of the syllabus, must be able to name at least one real situation where motion concepts predict or improve real outcomes. Think about engineering structural loads. Think about calibrating safety features like airbags in a car. We literally use the area under a motion graph to calculate the impulse and forces involved in a crash to keep passengers alive. It's used in optimizing massive public transport routes, analyzing kinetic energy systems, keeping communication satellites in orbit, advancing medical technology, and even tracking celestial bodies in astronomy. The source material for our explainer today strictly insists on an application-first teaching method. When you encounter a motion graph question on a paper 0625, grounding your answer in one of these physical realities shows the examiner you deeply understand the why behind the what. You're not just a robot spitting out formulas, you're a scientist analyzing the world.
Moving right along to section 2, upgrading from everyday to physics vocabulary.
This is a huge trap. When you look out the window of a moving car, you might casually say to your friend, "Oh, the car is getting faster." Or you might talk about the distance we covered. That's totally fine for normal life, but in the exam hall, that everyday language literally bleeds marks. You cannot write "getting faster" on an IGCSE paper and expect full credit. We absolutely have to upgrade to strict physics vocabulary. Instead of "getting faster," we need to mathematically analyze a speed-time graph slope and clearly state that a positive constant slope represents constant acceleration. Instead of just guessing the distance covered, we must explicitly state to the examiner that distance is calculated by finding the geometric area under that specific line on the graph. We also have to closely analyze the direction of the line and the overall shape of the curve. Is it a straight line? Is it curving upwards? Does that shape mean the acceleration is constant, increasing, or decreasing? Stressing exactly what slope, area, direction, or shape means physically is the ultimate bridge between a passing, average grade and an absolutely top-tier grade.
So this whole idea is summarized perfectly by this golden rule pulled straight from our source material. Insist on cause and effect rather than isolated facts. I really want you to let that sink in. Whether the topic on your paper involves motion graphs, magnetic fields, balanced forces, particle physics, parallel circuits, or transverse waves, examiners will always reward solid reasoning over rote memorization. They want to see the complete chain of events. What physical force causes the line on the speed-time graph to suddenly curve upwards? What is the tangible physical effect of that increasing slope? If you just write down isolated, unconnected facts, that's Alex's strategy. You might accidentally scrape 1 mark. But applying cause and effect reasoning, that unlocks the full 2, 3, or 4 marks for the question.
Before we continue, subscribe to our YouTube channel, Ace the Exams, at Ace the Exams IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
Let's get right back into it with Section 3, our 4 steps to success.
Okay, this is it. This is the exact step-by-step teaching sequence recommended to totally master IGCSE-style physics. You need to memorize this sequence. Step 1. Identify the quantity or phenomenon. What are you actually looking at? Is it velocity? Is it acceleration? Call it by its correct name. Step 2. State the relationship involved. Is it a directly proportional relationship? Is it inversely proportional? What is the specific mathematical equation that ties these variables together? Step 3. Explain the underlying physics. This is where you use that cause and effect we just talked about. Why is this happening? What are the forces doing? And finally, Step 4. Connect it to an observation, an experiment, or a real-world device. If you follow this sequence, you can't fail. It ensures you are showing the examiner both deep understanding and practical application. You aren't just reciting a textbook chapter, you are carefully building a logical, bulletproof scientific argument.
Now watch this. This 4-step sequence actually maps perfectly onto the famous Peel exam framework. You may have seen this in English or history, but it is just as lethal in physics. Step 1. Identifying the quantity is your point, or your definition. Step 2. Stating the relationship acts as your evidence straight from the graph. Step 3. The underlying physics is your deep explanation of the mechanics. And Step 4. Connecting it to reality is your link or application. This structural recipe guarantees maximum marks. Why? Because it aligns perfectly, 1-to-1, with how the examiner's actual mark scheme is designed. First, you define the concept. Then you relate the variables. Then you explain the physical cause. And finally, you apply it to the problem. When you execute this, those red pen marks from Sam and Alex's papers literally vanish, and all you see are green check marks. It's foolproof. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at AceTheExams_IGCS to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to at AceTheExams_IGCS and turn on all notifications so you never miss our weekly exam strategy sessions.
All right, you're subscribed and ready? Let's move into our interactive workshop for Section 4, Common Physics Exam Traps.
We are going to reverse engineer some of the most classic, painful errors we see students make on paper 0625. First major weakness, writing the correct formula but completely failing to explain the variables. The examiner sees you wrote V equals D over T, but if you don't define what those letters actually mean in the context of the specific car or train in the question, you lose the explanation mark. You literally threw it away. The MasterChef fix for this? Use Step 1 of our PL framework. Clearly state the definition and relationship. Second weakness, quoting a process without linking it to a physical effect. Just writing, the slope increases isn't enough to get the marks. The fix? You must use Step 3 and explain the full cause and effect chain. The slope increases, which means the acceleration is increasing, due to an unbalanced forward force acting on the object. Boom, full marks. Third weakness, giving a real-world example without showing why it follows the laws of physics. You might proudly write down airbags as a safety feature, but you don't justify it. The fix is step 4, application and justification. You must explicitly explain that airbags work because they increase the time of impact, which therefore reduces the overall force on the passenger, based on the physics of impulse shown by the area under the graph. See the difference? Okay, workshop time. Let's put this into practice right now. I'm putting 60 seconds on the mental clock. Imagine you're scanning a complex speed-time graph in the exam, and a student wrote this exact paragraph to describe it. Are you ready? Read it with me. The line goes up, which means it gets faster, so V equals d over t. All right, timer's ticking. Scan that sentence. Extract the core flaw using the examiner commentary we just learned. Think about it. Where did this student lose marks? Okay, time's up. Did you catch it? The flaw is literally everywhere. It's a disaster. First, the line goes up. What is this, a stock market chart? No, it's a positive gradient. That is everyday language, not physics vocabulary. Second, gets faster, completely ignores the core concept of constant acceleration shown by a straight angled slope. And finally, just randomly quoting V equals d over t without defining what distance or time they are talking about in context drops the final mark. It completely, utterly misses the Peel structure. If you spotted those flaws, congratulations, you are already thinking like a master chef.
So, let's summarize the complete, bulletproof physics answering system that ensures students like Alex and Sam can absolutely conquer Paper 0625. There are 3 absolute rules for top marks. Rule 1, command word decoding. You have to read the exact verb. If the question asks you to explain, you cannot just state a fact. You need the why. Rule 2, Peel framework application. Never just write a block of text. Always build your answers systematically with point, evidence, explanation, link. Rule 3, the time management matrix. Listen to me on this one. Do not spend 10 minutes writing a novel for a 2-mark question simply because you happen to know a lot of raw facts about it. Look at the marks available. 2 marks means roughly 2 minutes, 2 key points. Stick to the recipe.
Finally, let's bring it all together in Section 5, Key Exam Revision Prompts.
I want you to commit these 4 specific memory prompts to your brain right now. Take a screenshot if you have to. When you are revising any topic, ask yourself these 4 questions aloud. 1. What is the core idea? Be able to state it simply. 2. What changes physically in this scenario? What is the cause and effect? 3. What specific quantity or feature of the graph, like the slope, the area, or the shape, actually shows this physical change? And 4. Where is it used in the real world? How does this keep people safe or make machines work? If you can answer these 4 prompts out loud without peeking at your textbook notes, your knowledge is completely secure for any short answer or structured question Cambridge throws at you. You have truly mastered the application-first approach.
Students who implement these physics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. That is the difference between a C and an A, just by changing how you structure your thoughts.
Here's your final reminder. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by.
Drop a comment below with your target grade for physics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here. Keep analyzing, keep applying, and I will see you in the next strategy session.